Welcome to the Emotion Detection Enablers demonstration. In this demonstration, we are going to showcase Magic XRoom running with the enablers in real-time settings. Magic XRoom is a Unity VR application to collect data from a user. This data then is read and processed by Inference Tools to identify the user's emotions. The emotions, together with contextual information, will be used by the personalization tool to compute suggestions for personalizing the user's learning experience. This diagram shows the components and their connections. The creation of the marked connections is a work in progress. So, during this demonstration, the marked connections will be simulated since they are not yet in place. The diagram shows this demonstration setup, in which we are using two different machines to deploy the components. In the first machine, a Windows OS will run Magic XRoom that will write files with data. In the same machine, we also deployed the Inference preprocessing component that will read the files generated by Magic XRoom and send the processed information to the second machine. In the second machine, a Mac OS, we deployed the other Inference Tools components, the personalization tool and the demo UI. The demonstration screen is divided to show several components at the same time. In the middle left, we have the user playing the Magic XRoom scenarios. And in the top left, we can see the user's view from Magic XRoom. In the top right, we see the graphic interface from Demo UI. The graphic interface is divided into three sections. The left section is for the Unity simulation. Here, we can simulate the start and end activity signals and simulate the contextual information sent to the personalization tool. In this case, the contextual information corresponds to the user and the activity levels. In the middle section, we are displaying the output of the inference tools, i.e., the user's detected emotions. In the right section, we are displaying the output of the personalization tool. In the bottom right of the screen, we see the inference preprocessing component that will read the data files generated by Magic XRoom and send the processed information to the other machine. The inference preprocessing keeps waiting for files, and as soon as the user presses the data collection button in the Magic XRoom, Magic XRoom starts to generate new data files, and inference preprocessing starts to read and process them. The processed data is sent to the rest of the inference tools that will identify the user's emotions. When we press the Start Activity button, the personalization tool will start to listen to the user's emotions, and when the Stop Activity button is pressed, the personalization tool will compute a suggestion based on the user's emotion and contextual information. We can see in the middle section of the demo UI the emotions being identified. And when the Stop Activity button is pressed, the personalization tool suggestion is displayed in the right section. We have another example with the user playing a different scenario from Magic XRoom. In the bottom right corner, we see the inference preprocessing component waiting for new data files. And as soon as the user starts the data collection within Magic XRoom, the application will start writing data files. The inference preprocessing then will read, process, and send the information to the rest of the inference tools that will then, using a trained emotional recognition AI model, identify the user's emotions. we can visualize in the identified emotions in the middle section of the demo UI. The trained emotion recognition AI model being used here was trained using data collected during the pilot sessions of the XR2Learn data collection. As mentioned before, when the personalization tool receives the stop activity message by us pressing the stop activity button, the personalization tool processes the user's emotions and the contextual information to suggest an adaptation action, in this case in the form of the activity level adjustment.